Every single day, more than 27,000 people are diagnosed with tuberculosis, and every day, over 3,000 of them don't survive. Tuberculosis is one of the deadliest infectious diseases on the planet, and it's still here. Here's the thing, we already have a simple, affordable way to screen for tuberculosis: chest x rays. The problem? Reading those x rays takes a trained radiologist, and in the regions hit hardest by tuberculosis, like low and middle income countries, there simply aren't enough of them. So what happens? Diagnosis gets delayed, cases get missed, and people go home thinking they are fine when they are not. What if a computer could read those x-rays accurately, instantly, and at a scale?
That's what we built. We trained a deep learning model based on ResNet 50 to automatically detect TB from chest X-ray image. But we didn't train it the usual way. We used a two-phase strategy. First, the model learns with its core knowledge locked in place, like a medical student studying textbook. Then we unlock the deeper layer and let it fine-tune specifically for TB patterns, like that same student starting clinical rotation. And we didn't rely on single dataset. We combined three public datasets from China, the United States, and Bangladesh, with 2,000 chest X-ray in total. That diversity helps the model handle the real world, where X-ray come from different machines, different population, different condition.
The result? Our model reached 92% accuracy and an AUC of 97.8%, meaning it reliably tells TB and normal cases apart across nearly every decision threshold. And to make sure it wasn't a fluke, we ran 5-fold cross-validation and the performance held steady. But here's what makes it trustworthy. Using a technique called GradCam, we can actually see where the model is looking, and it looks exactly where a radiologist would. It looks at the lung region where TB shows up. It's not a black box, it shows it works. This isn't about replacing radiologists, it's about giving them a tool, an extra set of eyes, especially where there aren't enough doctors to go around. Because no one should die from a disease that a single chest X-ray could have caught. That's the future we are building toward.